Do you want us to talk or no?
No. Just kidding. Okay. All right. So, what was the vertex? Let's phrase it. How do we find the vertex of the first form? The little formula.
Oh.
The baby formula.
Something over something.
Pretty good question.
If you know the quadratic formula, you also know this little formula.
Is it little?
Yes.
Yeah, it's pretty.
It's little.
Is it just the
B over X. Wait. No.
Oh yeah, it's something like
B
that.
squared over something.
Yeah, it's to that effect.
I'm sure in my head, but it's like fuzzy. Oh yeah, it's like two. You've got this look on your face that says we are so incredibly
2A over
wrong.
B. Oh, negative B over 2A.
Oh, don't say negative. Oh, opposite of B over 2A. So that keeps you from the double negatives. Okay, so if you look at your B value and let's say it's -4, well then there's no point in you putting -4 because you're so used to saying negative B over 2A. Just say the opposite. So if it's a -4, it's now a positive. Okay, it's a whole lot simpler. Same as with the quadratic formula. Okay, so if we know our X value and we're trying to find an ordered pair, how do we find our Y value? Plug it in. Substitute it in. Okay, so another way to say that would be if we plugged in, in other words, f of that. Okay, so this is a lot of math, lingo terms and all that stuff too. You can write off to the side, plug it in. Okay, but that's what that means. F of whatever we got, we're just going to plug it back in. Okay, so our axis of symmetry is what goes straight down your vertex. Okay, so if you think about if I drew a dotted line down the middle of my face, I have an eyeball here, I have an eyeball there, I have an ear here, I have an ear there. Okay, so your axis of symmetry is going to cut straight down the middle of your graph. So your if you hold on, let me get my bearing straight here. For your axis of symmetry, it is just the X value of your vertex. And I will be picky, okay? You are now in state dual-wide credit pre-cal, okay? This is an equation of a line. You must put X equals. You can't just put 2. You can't just put 5, okay? You have to put X equals. I will count off. Ordered pairs. If you don't put them as ordered pairs, I will count off, okay? So our y-intercept, that's where it crosses our y-axis. So what would that be in this kind of form?
The C value.
Our C value. So again, we'll just write that as 0, C. Our x-intercepts will come from either factoring, quadratic formula, or graphing, or anything of those natures. They're just going to be our x value and 0. Majority of the time, you're going to have 2 of them. Sometimes you'll just have 1. And that's called a double break. Okay, what's the domain of every single parabola? All real numbers, negative infinity to positive infinity. Always. And our range is going to be dependent on the way our graph is facing. So if our graph is facing up, bless you, then it's going to be anywhere greater than that value. Okay, so if we have y is greater than, I don't know, let's say that's 2 or something like that, then we would say 2 to infinity. So the best play, actually, you know what, let's generalize this. the y value of our vertex. Same thing goes, it would be the y value of our vertex to infinity. Okay. If it was facing down, it would be less than our y value of our vertex. And we would have negative infinity to that y value. Okay. So that just depends on which way it opens, if it opens up or down. So that probably would have been one lesson, one day. Okay. Then the next day, you would have probably talked about the vertex form. Okay, in this case, they call it the standard form. It's called the vertex form for real because you literally should be able to pull out your vertex. Side note, H is the opposite of what you see. So if H is -5, then the part of your vertex is going to be a +5. If H is -6, it's going to be a +6. Or if it's a +6, it's going to be a -6, okay? H is always going to be the opposite. Axis of symmetry is still our x value of our vertex, so x equals H. Our y-intercept is not as easy as the general form over there. We can't just plug in 0 and get just our c value. We're still going to plug in 0 because x is still 0 on the y-axis. But then you'll actually have to do a little bit more work to figure out what your actual value is. So you plug in 0 for x and then solve for y. X-intercepts are still the same. You'll have to solve for those. Domain is still the same and range is still the same. Okay. So that would have been another day. So already day 1 of this chapter, when I talk about doing the one-sheeter, there's already a lot of information you can put on there. Okay. Because this is the stuff that, if you remember any math lesson, the first section is the one you always forget. Okay. So don't let that be this one. Okay. Questions so far? Hopefully it's coming back to you a little bit. Okay. So I've given you the vertex. I've given you a point. I want you to write the equation in both forms. Okay. So think about it for a second. I'm giving you the vertex and I'm giving you a point. Which form do I start off with? The vertex form, or their standard form, or whatever it is. Okay? So y equals a times x minus h squared plus k. So let's plug in what we know. So our vertex is our hk, and the point is our xy. So let's plug that in. Y is -6. We don't know what a is. X is 3. H is 1. And k is 2. Go ahead and use your order of operations and solve for a. I guess the backwards of order of operations. So 3 minus 1 gets me 2. 2 squared gets me 4. Subtract my 2. And divide by 4. So far, I have one of my equations, and that's going to be y equals negative 2, x minus 1 squared plus 2. So I plug my vertex back in now with my a value. Okay? Now, how do I go from that form to general form?
Simplify it like you just do the multiplication.
Yeah, simplify it as multiply, okay? So we're going to write this out as negative 2. Please do not say that's x squared minus 1. Please. Go ahead and simplify that out. And you should get your general form.
Oh, that's much easier than what I understood.
Make it harder on yourself.
I mean, I wouldn't say harder,
Okay.
but I prefer to do that.
All right, so you can do this a couple of different ways, but I prefer to go ahead and knock out the x minus 1s being multiplied together. And then distribute my negative 2. And then combine like terms. So negative 2x squared plus 4x. So now I have both my, what they call standard form and general form, okay? Questions so far? The good old algebra stuff. Just multiplying it out. The good stuff. Okay, try that one up there. Your vertex is 4, 1, and your point is 6, negative 7. Did anyone still need the bottom part? I scrolled it. Should have asked. this one also ends up being -2 for our a value. So we get y equals -2, x minus 4 squared, plus 1. Okay. And if I multiply that out, I'll get y equals -2x squared plus 16x. That gets me a -32 plus 1 gets me a -31. Okay. Questions so far on that? Remember with this stuff, show me as much work as possible on a test, so that way I can give you credit in case you accidentally said 6 minus 4 was 10. Trust me, we've all been there. Okay, we start mixing things up in our head. All right. I had a slide, and I'm not finding it. Or I can just assume you already know it. Transformations. You should know it. Let's see what you can do.
Wait. No, okay.
We already did them, right? In the first chapter?
Yeah, we did.
Yeah, okay. Go ahead and list any transformations that are happening here. I forgot we did them in the first chapter too. Hey, it saves y'all from writing all that stuff again.
How could I forget that strange packet?
It was not strange.
No, the notes were fine. It was the work that I was like, I don't know what I'm
The
supposed
homework?
to do. Yeah, I was like, what is this?
Because it was different than bookwork?
Yes.
Yeah. Stretched your thinking a little bit?
Well, it's hard to stretch limitless possibilities.
Limitless possibilities. Wow. Interesting. So again, already we've got vertex form, standard form, and general form. All the details about that. Now we're throwing in transformations again. So that's a lot of details there. We're just in the first section. All right, who wants to tell me my transformations in part A? Anybody?
Would you like me to?
Yes. Yeah.
Are you volunteering yourself?
I volunteer to trigger.
Okay, please tell me.
It's a vertical compression by 2 or 1/2, whatever.
By 1/2.
It's upwind. Did you count? Because like just by the language, like vertical compression by 1/2, it's like it seems like backwards. Like you say vertical compression by 2.
The horizontal is backwards.
Yeah, but you're compressing it by 2. You're not compressing it by 1/2, because if you were compressing
You're
it by
cutting
1/2,
it 1/2.
well, yeah, but you're compressing it by 2. Not 1/2.
You're cutting all of your y values in half, so you're dividing by 2. You're not.
Correct. So you're compressing it by 2, but you're not multiplying by 2. You're multiplying by 1.
Whatever helps you remember it.
Well, I'm asking you because I'm going to put by 2 in the test
Or 1/2.
because my pride gets in the way.
You are very stubborn. I am too, though.
I know.
But I have power.
I
It's the only power I have.
It's okay.
All right, who's got part B? Okay.
It's a vertical compression by 1/2, and it shifts 4 to the right.
Awesome.
Do you want to put in the sub plans that you were busy?
I'm sorry.
Do you want to put in my sub plans that you were busy doing stuff on Friday?
She's got things, at least I was able to list her things. Mine would be like, just disappear.
Medicare would be like, she's not here.
She's just not here.
All right. What about part C? Who's got that one?
Left x-axis, left 3 up 5.
Wait, start over again.
Left x-axis,
Reflect x-axis.
left 3 up 5.
You seem so excited about that.
I'm not.
Uh,
I wanted to be done.
Grumpy? Do you go back to bed and wake up on the right side?
I woke up on my outside. I'm just gonna go back. Oh, I have a right side. It's just one side.
All right, so we're gonna graph these by hand. Couple different ways you can do this by transformations. You can do it by knowing the different forms, by finding the vertex. It's up to you, okay? So which way does this graph open? Up. How do you know that? A is positive, okay? A is 1/2 in this case. Now, you can argue that this is either one of the forms. You can say this is in general form, or you can argue that it can be written in vertex form, okay? Because of that 0. To me, that's a whole lot easier because I get to pull out the vertex, okay? So 0, 1. Which you would have also gotten if you did opposite of 0 divided by 2 times 1/2. Our axis of symmetry, again, is still the x value of our vertex. And I have parent function on there in case you wanted to graph it by doing transformations, which is just x squared, of course. That's only if you were going to do transformations, but I'm going to show you both. Okay. So if our vertex is at 0, 1, that's not right. That's 1, 0. 0, 1. Good morning. Okay. The axis of symmetry goes straight down it. And no, we are not sketching and just going, okay, calling it a day. All right, I want actual legit points. So usually what I do, if you had a teacher that taught you by steps, I don't know if any of y'all's teachers taught you a little pattern that you can use. I just go on either side of the axis of symmetry and plug it in, okay? So for example, if my axis of symmetry is at 0, I might take 1 and plug it into that equation. So 1/2 times 1 plus 1 is just 1.5. So that's one way of doing it. Since I know this is a vertical compression, I'm going to probably pick even numbers to plug in. So if I plugged in 2, I get 1/2 times 2 squared plus 1, which is 1/2 times 4, which is 2. And 2 plus 1 gets me 3. Up across the axis of symmetry, you have your other dot, okay? You need at least 3 points to draw your graph, okay? After that, you can just sketch it, okay? So let's say I wanted you to do this by transformations, which I would never specify doing it that way. However you want to graph it, okay? But if I did tell you, what you would do is you would take every one of your y values and you would multiply it by 1/2. Okay? So if originally I had a y value, at 1, gosh, this thing is so sensitive. So if that's our parent function that we learned from the project, I would take every single one of my y values and multiply it by 1/2, so I'd be at 1/2 here, and then you would shift it up 1. Same thing here, if I took 0 and multiplied it by 1/2, I'm still at 0, and I move it up 1. If I take this y value here, which is 4, it cuts me down to 2, and then up 1. That's how I'm at 3, okay? So if you want to do it by transformations, go for it. If you want to do it by just graphing it by knowing the vertex, go for it. I could care less either way, as long as you're graphing it. I mean, you can make a table of values all day long if you wanted to and do neither one of these options, okay? All right, you try this one. Yesterday, they sent out the formula sheet for y'all's challenge exam that's at the end of the year. Y'all will never guess what formula is on it.
Okay.
No. I think that one, it might be on there too, but. Slope intercept form. They have a box that says y equals mx plus b. Just in case.
That one's hard to remember.
Yeah. I haven't been told that for 4 years. I've never.
But still, like, y equals mx plus b. Give you something harder than that to, like, I mean, that you can at least.
Don't, please don't.
Well, I mean, I'm saying, like, you would rather have a formula for double or half angle or something like that
Yeah,
than y equals mx plus b.
I found this old book that gives you every value for cosine, sine, and tangent.
That's not possible.
It gives you like you go down it has like a table. It's ridiculous. It's from like the 60s. Like
Yeah.
and it's like
Because it goes on forever. That's why I said it's not possible.
It gives you every value, like up to 100. Why I would hate to have to use this.
Kind of like a lot of the digits of pi. I can't remember how many there are here.
I know all of
Yeah, count them and we'll leave. I guess
One, two. If I did it. I would probably lose my mind.
You would not leave. You would be here for a while.
Okay, which way does this open? Up. What's my vertex? 4, 0. So my axis of symmetry is x equals 4. And of course, this is still y equals x squared. Okay, so if I plot the point 4, 0, and I have my axis of symmetry that cuts straight down, please. And then if I plug in, let's say 3. I'm not going to get a pretty thing because I'm dealing with halves. So let's plug in 2. So 1/2, 2 minus 4 squared. 2 minus 4 is -2. -2 squared is 4. Half of 4 is 2. So I'm going to plot the point 2, 2. Hop across the axis of symmetry. And I have my 3 points. Okay. Again, if you did it by transformations, you would take every single point, every single y value, divide it by 2, and then move it to the right 4. 3 total. Because a lot of people will just give me the vertex and go and be done. Okay, I need to see at least that you know the next point. Now, if you're ever doing like systems of equations where you need to find intersection points, then you need to do more than just the 3. Because you need to actually figure out where it intersects. Okay? Questions? Let's see. Do one more. And then we're going to go the opposite direction on the equations, and then we'll be done. So this one opens which way? Down. My vertex is -3, 5. Which means my axis of symmetry is x equals -3, and we're still dealing with a quadratic. So I plot the point -3, +5. So if you're someone that maybe got that backwards and did 3, 5 on that one sheeter, I'd probably put on there again. Don't forget, H is the opposite. Okay? Little details like that will help you constantly studying for this test. Okay? So if I plug in -3, nope, -2, sorry. -2. I get 1 squared, then that becomes a -1 plus 5, gets me 4. And hop across the axis of symmetry.
If you know the standard opening, you have to like plug it in.
I'm sorry?
If you know the standard opening, you have to plug it in.
No, if you know that it's not going to have a vertical stretch or compression, then you're good. Okay. So it seems so silly to write whether it opens up or down. But let's say I plugged in 1 and I got 6. Okay. And all of a sudden the graph is facing up. That's just a quick reminder. Okay, this should be facing down. I added wrong, I multiplied wrong, whatever. I can double check that way. Okay. All right, so one last thing. Which we'll do both ways. So, completing the square. Ooh, that was a little bit ago. So, completing the square, there's also another little formula that goes with that one. I'm going to go through how to change this general form. It's really hard for me to get those two names down. To vertex form, or to find the vertex, or anything of that nature. I'm going to go through 2 different ways of doing this. Okay. So either way that you feel comfortable doing it, go for it. So, completing the square is we are going to take our b value divide it by 2 and square it. Okay? I'm going to take my b value, divide it by 2, and square it. I put blanks in there because that's where that answer is going to go. Okay, I put 2 blanks because we can't just throw in a number to an equation because we want to. We have to add 0 to the equation because we're just changing the way it looks. We cannot change the value of the problem. Okay, so b in this case is -8. -8 divided by 2 is -4. Do what? Right. That's another way I'm going to show you in a second. So if we get 16 here, then we also have to do a -16 there. So yes, we end up with the same exact thing, because if you notice, what are 2 numbers that multiply to get 16 but add to get -8? -4 and -4, which is already completing the square. Anyways, so we get x minus 4 squared, and then plus 0, but we don't put that. Okay? So technically, I can find my vertex that way. And I would say my vertex is or 0. I could find my vertex doing the opposite of b over 2a. And that would also get me my vertex, okay? But switching between the two forms can be a lot easier if you do just find the vertex, because if you notice on the examples we did at the beginning, notice how your a value here is the same a value here. The a value here is the same a value there. So really, if you're going from what they consider general form to vertex form or standard form, whatever they want to call it, then your a values are going to be the same. So for example, let me show you one where it doesn't work out that way. Let's do x squared plus 4x plus, no, that could be factored. Let's do 7. So let's say they wanted you to go from this form to the vertex form, okay? One way is I can find the actual vertex. Like we did at the beginning. So then we would have negative 2 squared plus 4 times negative 2 plus 7. So 4 minus 8 plus 7, which gives me negative 4 plus 7. So 3. Your a value is going to be the same. So if the a value is 1 there, and we have our vertex, we have our new equation. So that's one, oops, that's a plus. That's one way of doing it, okay? Or you can complete the square. So I don't, like I said, I don't care which way you do it, okay? So if I complete the square, oops. And I said b divided by 2 and square it. So b divided by 2 is 2. Squared is 4. So then this would be a minus 4. So then factors of 4 that get me 4 are just 2 and 2. So y equals x plus 2 squared plus 3. Either way, like I said, I don't care if you want to just, hey, I know how to find the vertex, I'm good. I'll just find the vertex and plug it into the equation. Or some of us remember completing the square, and you can complete the square, okay? I don't care which method of madness you want to use. Questions on that? What you can't do is complete the square when you have a leading coefficient other than 1. You would have to get rid of that 1 or that number or something like that, okay? So whichever method of madness you want to use, I've got one more example for you. Do it.
That answered my question.
Oh, I was waiting on people to finish writing. I'll show you how to do both. Solve by just finding the vertex. Opposite of B over 2 times A. Gives me -2/-2, which is just 1. If I plug that back in, I get -1 plus 2, which is 1. Plus 5 gets me 6. My A value stays the same, so I would just write it as -1, or you don't even have to put the 1 there. X minus 1 squared plus 6. That's one way. If you completed the square, you would have had to take out the -1 first. So then -2 divided by 2 gets me -1. -1 squared is 1. But notice, this is attached to a -1. If we're adding 0 into this, then this is -1. This needs to be a positive 1. Okay? So then now we have negative factors of 1 that get me -2, or -1 and -1. And then 5 plus 1 is 6. So again, I don't care which approach you took, as long as you showed your work and got the right answer. Any questions on that?